Assalamualaikum warahmatullahi wabarakatuh. My name is Nurfatin Alia binti Azhari. My matrix number is AA 2098. So today I will present about the fluid mechanic project. My group member is Nurfara Wahida binti Ismail and Maisara binti Muhammad Nabi. We are from group 9 section 3. So for our project, the title is about the deep tunnel sewerage system DTSS in Singapore. So I will present about the introduction for our project. Our project name is Deep Tunnel Sewerage System DTSS Phase 2. The location for our project is at western part in Singapore. The status is Phase 2 started in 2014 with award of contract for professional engineering service. And also the site area for our project is 60 km link sewer, 40 km deep tunnels, initial treatment capacity 80,000 km per day. The client or the owner for our project is PUB and also Singapore's National Water Agency. This project involve and tap on expertise of many local international partners in delivering project. So for this project have their own objective. The first objective is to meet the long-term needs of Singapore for use water collection, treatment, reclamation and disposal. Other than that, the objective is ensuring new water sustainability, which is to collect used water from western and southern parts of Singapore. Other than that, the objective for environmental protection, which is enhance reliability of used water system, minimize risk of contamination between water catchment and used water system. And used water system transported separately by gravity from municipal and industrial source to new water towards WRP via conveyance system. The last objective for optimizing land, which is just use 50% reduction in land taken up by used water infrastructure.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurfara Wahida binti Ismail. Today I will present about construction process for deep tunnel sewage system phase 2. Deep tunnel sewage system phase 2 consists of 40 km of tunnel with internal diameter of 3 meter to 6 meter, 60 km link sewage with internal diameter of 0.3 meter to 3 meter and a 176 mgd plant at west with a 25 mgd new water capacity. Includes construction of hydraulic structure and a management facility. Firstly is geology. The deep tunnel sewage system phase 2 tunnel is expected to go through rock and expect to go through soil. There will also be many locations where the DTSS phase 2 tunnel will encounter mixed phase condition. Second, tunnel inspection. The deep tunnel sewage system phase 2 tunnel will be designed with the provision for tunnel inspection by remotely operated vehicle. DTSS phase 2 tunnel will have only one line shaft. For the third phase is tunnel monitoring. As an added feature, the DTSS phase 2 will also explore the use of fiber optic cable cast into the tunnel leaning for structural integrity monitoring. Longitudinal installation fiber optic cable cast directly into CPL during its construction. Next, fourth, air management. The tunnel convey both used water and air to control the flow of this air and to prevent any other nuisance. Air management facility will be installed wherever link sewer connects to the tunnel. This air management facility consists of both odor control facility and air jumper. The other control facility draws air from both link sewer and tunnel and treats the air before releasing it back to the atmosphere. Negative pressure in tunnel may not be sufficient to pull incoming link sewer air. Air jumper force the air into tunnel, and air jumper serve as forced ventilation to prevent air from the link sure to tunnel from escaping into the surroundings. 5. Tunnel isolation. Another new feature in the DTSS Phase 2 tunnel is the ability to isolate sections of the tunnel using gates. A gate can be lowered in the shaft to block flow in the tunnel. The gates to be used in the tunnel will be roller gates. Large section drop-in gates used for isolation within combined sewer tunnel convection system. 6. BIM Building Information Modeling will be a mandatory requirement for DTSS Phase 2. And the last is IDMS, Integrate Data Management System. An Integrate Data Management System will also be introduced in the DTSS Phase 2 project for the tracking of construction data so that all parties will be updated with real-time information on the progress of the construction and associated instrumentation readings. That's all from me. Thank you.
So, for this project, the technology is being used is towards water reclamation plant. This is the advanced technology to improve energy efficiency. This is also use less power than conventional plants. This also decrease waste and highly automated to minimize needs for manpower. This technology also receive use water flow from western parts of Singapore by gravity via two separate deep tunnels, which is tunnel to convey domestic municipal use water and also tunnel to convey high-strength industrial use water. This source of use water will treated separately. So, for this system can collect and treat domestic, also industrial use water separately, ensuring the safety and high quality of the new water supply. This is compactly designed towards water reclamation plant with treat highest average flow on one of the smaller land area. This conveyance system leverages advanced technologies to manage both used water and airflow whilst enabling easier monitoring and maintenance.
Assalamualaikum. My name is Maisara binti Muhammad Nabi and my metric number is AA200330. I will continue with issues in constructing deep tunnel sewerage system. One of the challenges faced in the project is optimizing the amount of space used in order to reduce the amount of land needed while still giving high quality output. The second issue is the tunnels run through challenging ground conditions that require careful engineering to ensure the stability. For the conclusion, the Deep Tunnel Sewerage System project intends to improve Singapore's water transportation and treatment system while also lowering the amount of land taken up by used water infrastructure on the island by half. The completion of DTSS Phase 1 has reduced the land previously used by the WRPs and intermediate pumping stations from 300 hectare to 190 hectare. Phase 2 is further expected to reduce the land to 150 hectare. The freed up land can then be used for other higher value developments. This project is also designed to efficiently recycle used water with minimal environmental pollution. Some recommendations that can be used to face the issues earlier is to improve the design features such as double stacking, building upwards, and allowing for natural ventilation and lighting. Secondly, we can improve by tackling the challenging ground conditions by working with various authorities and archaeology specialists in different regions.